Section 1.3, Properties of Functions. So once we know about symmetries, specifically symmetries with respect to the y-axis and origin symmetry, once we know that we have a function in addition to those symmetries, we can actually talk about something called an even and an odd function. So if the graph of f of x is symmetric with respect to the y-axis, then we're going to say that the function f of x is an even function. And it's true that f of negative x is equal to f of x. Notice that this is really that algebraic test that we learned when we talked about y-axis symmetry. Similarly, if the graph of f of x is symmetric with respect to the origin, then the function f of x is what we call an odd function. And that is f of negative x is really the same thing as negative f of x. This is the exact same algebraic test as we did with the origin symmetry. It's just going to be a little bit easier because you'll be able to just plug in negative x, see what you get, and then you can discover if you have an even or an odd function. So first we want to describe the symmetry of the following graphs. So we have this graph. Does it have any symmetry? And the answer is yes, it has x-axis symmetry. Notice that it mirrors above and below the x-axis. So we do have x-axis symmetry. Next we want to know, is this an even odd function or neither? Well, we really have to answer the question first, is this a function? And notice that if I try to do a vertical line test, it fails the vertical line test because it hits the function in 2 points or more than one. And because of that, we know we do not have a function, and so this thing is neither even nor odd, namely because it's not a function in the first place. Then we see this line. We want to describe the symmetries it has. Does it have x-axis, y-axis, or origin symmetry? And the answer is no. We don't have any mirroring across the y-axis, no mirroring across the x-axis, and no rotational symmetry. Is it a function? Yes, it does pass the vertical line test, but because it had no symmetry, then this thing is neither even nor odd. Then we see this one. We ask ourselves, does it have any symmetry? And the answer is yes, it has y-axis symmetry. So we have y-axis symmetry. Then we need to know, is it a function? And the answer is yes, it will pass the vertical line test, and since it will, we can say that this thing is not only y-axis symmetric, but since it's a function, that also means that it's even. Now we want to talk about x-axis, y-axis, or origin symmetry. Well, this one has x-axis symmetry. It mirrors above and below the x-axis. It has y-axis symmetry, that is, it mirrors to the left and right of the y-axis. And then origin symmetry, if you were to take this function and rotate it 180 degrees, this thing would give you the exact same function upside down that it did to begin with, so it does have origin symmetry. Then we ask ourselves, is this a function? But this thing is not a function. Anywhere we take and try the vertical line test, we're going to touch the graph in more than one place. And so this thing is not a function, and so it can't be even or odd. Once again, to determine if a function is even or odd algebraically, we're just going to replace x with negative x. And this is really great because instead of having to do two separate tests for y-axis symmetry and origin symmetry, we're only going to have to do one test and see what we get in the end. So if you plug in negative x into the function and you get the same function you started with after simplification, then that function is even. If you can factor out a negative and it's negative times the entire original function, then we can say that that function is odd, which means that it has origin symmetry. And if neither occur, then neither is true. It's not even, it's not odd. So let's determine algebraically whether the given functions are even, odd, or neither. Step 1, plug in negative x. That is 4 times negative x to the fourth. Simplify as much as possible, but negative x raised to the fourth power leaves me with x times x to the fourth because negative 1 to the fourth power is really positive 1. Notice that this is the exact same function we get in the end. That is, this is the function f of x. So really I have the statement f of negative x is equal to f of x, and if we get that, that means that we have even function. Then let's try this one. So f of negative x is 9 times negative x plus the absolute value of 3 times negative x. Then simplify as much as possible. That's going to be negative 9x plus the absolute value of negative 3x is really just the absolute value of 3x. Then you ask, is this the same function we started with? Well, it's not the same function we started with, so it can't be even. The only other thing to try is to factor out a negative 1. But if we factor out a negative 1, what are we going to get? We're going to get 9x minus absolute value of 3x. Then notice that this is not the same function we started with. And so it's not negative f of x, which means that this thing is neither. Now let's try this one. F of negative x, that's going to give us negative 9 times negative x cubed divided by 3 times negative x squared plus 6. Then negative x quantity cubed brings a negative out, so that's going to be positive 9, because 9 times negative 1 is positive 9, x cubed, divided by negative x quantity squared. That's going to leave us with 3 times x squared plus 6. And then this is not the same function we started with, so we can go ahead and say it's not even. But we do need to factor out a negative 1 and try to see if we get negative f of x. So factor out a negative 1, then I'm going to decide on top or bottom, but I notice that the bottom is already matching the denominator here, and so I'm going to factor that negative out of the top, which then leaves me with a negative 9x cubed divided by 3x squared plus 6. At this point, notice that that is really negative times the function f of x, because this right here is our original function. It's exactly the same. So then we can say that this one is an odd function. If the graph of the function rises as we move from left to right on some interval, we're going to say that that function is increasing on that interval. If the graph of the function falls from left to right on an interval, we're going to say that that function is decreasing on that interval. If the function values stay the same on an interval, we're going to say that that function is constant on that interval. F of c is a relative maximum if Cf of c is the highest point in some open interval. Now by open interval, I mean that you can take your hands on both sides, encapsulate around a point, and as long as it's the highest point inside your hands, it is a relative maximum. Similarly, f of c is a relative minimum if Cf of c is the lowest point in some open interval. And once again, to visualize this, if you pick a graph and you put your hands around some point, if you can move your hands out or in such that that point is the largest value in between your hands, then it's a relative minimum. F of c is the absolute maximum if Cf of c is the highest point in the entire domain of the function. And so once you know the domain, if it is the absolute largest value for the entire function, it's an absolute maximum. F of c is the absolute minimum if Cf of c is the lowest point in the entire domain of the function. That is, if everywhere on the graph one point is lower than all other points, it's an absolute minimum. So we're going to use the graph to determine the following. Let's start with the domain. Understand that when we're looking for the domain, that is all the x values that occur on the graph. And so we should really, if you want, you can approach this with a vertical line that goes forever and ever in both directions. And if you start way over at negative infinity and you start approaching the graph, you really want to know when are you touching values on the graph with that line that infinitely goes up and down. And so notice that there's nothing until we get to negative 6 here. Then I'm touching values on the graph. So I can actually say that my domain begins at negative 6. Now the order in which you write these matter. We do want them from least to greatest. So most negative thing on the left, most positive thing on the right. I say most negative and most positive. They won't necessarily be negative or positive, but just the furthest to the left and the furthest to the right on a number line. Well then, we started here at negative 6 and we get values on the graph. Because I have this solid dot here, it actually does include that value. It actually exists. Then we just keep moving with that vertical line and we say, where are we not touching the function anymore? And in truth, we keep touching it until we get to positive 6. And so I know that the domain stops at positive 6 because there's no more graph after that. And then because of this solid dot, I know that this thing is inclusive, that is 6 is included. Range is similar, but now you're going to work on the y values, that is start from the bottom, and use a horizontal line that continues forever in both directions and ask yourself, when do you start touching the graph as you move your way up? And the answer is I begin touching at negative 2. And so the range values begin at negative 2. Notice that this is a solid dot at negative 2, which means it's included, so we use a bracket. Then I continue with this infinite horizontal line and say, when do I stop touching values of the graph? And the answer is right here, at 4. 4 are the last values that occur, and I notice that nothing else occurs after that. So that means my range values go from negative 2 up to 4, and because of the solid dots and this line segment, this thing is also included. Then we need to know what the intercepts are, but notice that's just anywhere we cross an axis, x or y, and so I get the intercepts of negative 6, 0, negative 2, 0, 0, 4. Then we want to know, is this even, odd, or neither? Well, first question is it a function? And the answer is yes, it passes the vertical line test, so it's a function. Next, ask yourself, do you have any symmetry? And I don't see any y-axis symmetry, and I don't see any origin symmetry. Remember that if you have a function, you'll never have x-axis symmetry. Then we know that this is neither even nor odd. But now we need to talk about where is this function increasing, decreasing, and constant. So for increasing, I'm going to look for anywhere that I rise as I move from left to right. So notice that from here to here I'm going up, and that's the only section. And so that is, we're going to answer this in terms of the x values. Always the x values in terms of increasing, decreasing, and constant. And that first x value is -4, and then I'm increasing up to the x value 0. But then for the sake of this text, we are going to use brackets to include those endpoints because they do exist. Then we want to know, where is this function decreasing? So similar game, as we read it left to right, where does it move down? Well, this is decreasing, and this is decreasing. Once again, to label these things, we start decreasing at -6, labeled in terms of the x values, and stop decreasing at -4. And for the sake of this text, we are going to use a bracket to include those values. Union, it picks back up again as decreasing at 3. We will use a bracket because the point does exist, and we're going to continue to decrease until +6. And we will use a bracket because that value does exist. Then, where is this function constant? Well, the constant values, that is not increasing or decreasing as we move left to right. That right there is the traced constant part of the function. Notice that those endpoints really do exist, so it's going to be constant on the bracket from 0 up to 3 inclusive. Now we need to answer the question, is there an absolute maximum? And there won't always be. There won't always be an absolute maximum or an absolute minimum. But for this one, I claim that there is. So that is, find the largest value that exists on the graph. Well, notice that the largest values actually occur on this entire line segment from this point to this point. The fact that they repeat doesn't really matter. But when we ask what the absolute maximum is, the absolute maximum is actually the value 4. We're always going to answer absolute maxes and absolute mins in terms of the y value. But understand that we might have to also answer where they occur. That's a different question. Where they occur is at the x values they occur. And so specifically, it is going to occur at the x values. And I'm going to use some mathematical notation. The x values that are in the interval 0 and 3. And so this is a lowercase epsilon, that is the x values in the interval from 0 to 3, including 0 and 3. And so if you were asked for the location of the absolute maximum, this interval would be the answer here. But what is the maximum? 4 is the maximum. Now we need to discuss the absolute minimum. Notice that there is a smallest value that occurs. There it is. That's the smallest value that occurs on the graph. Thus, the absolute minimum is actually the value -2. Once again, we'll answer what is the absolute max or min in terms of the y value. But where does it occur? Well, specifically, it's going to occur at the x value, -4. So two different questions. Using this graph, we want to first determine its domain. Once again, use an infinitely vertical line as we cross from left to right of this graph. That is, as I move from left to right, my first value that I touch on the graph is here at -10. And because it's a solid dot, it is included, so it starts at -10 with a square bracket. Then my vertical line that goes forever and ever up and down as we go across. When do I stop touching function values? And the answer is here at 7, and then there's nothing to the right of that, so that goes up to +7. 7's a solid dot, so it's a square bracket because it's included. Range, use an infinite horizontal line, start from the very bottom, and ask yourself, when do you start touching function values? And the answer is you begin touching at -4. So, -4 is our first range value. It is a solid dot, so it's inclusive with a square bracket. Then that infinite horizontal line moves up until we get to 210. But we need to answer that in terms of the y value, so that value is the value 10, and it's a solid dot, so it stops with a bracket after 10. Then find the intercepts. That's just anywhere it crosses an axis or touches an axis. And so our intercepts are -10, 0, -5, 0, 0, 0, and 5, 0. Now we want to know, is this function even, odd, or neither? Well, first, is it a function? And the answer is yes, it passes the vertical line test. Next question, does it have any symmetry, specifically y-axis symmetry or origin symmetry? It has neither of those, and therefore it's neither even nor odd. Where is this function increasing? Notice that it begins increasing here and increases till here, and then it also increases from here to here, and it increases from here to here. So it's increasing on the intervals between bracket -8 up to -2, close bracket, because those are solid dots, we are going to include them on our interval, then union to glue it together, and then this starts at the x value 0, It's a solid dot, so we're going to include that value with a 0, and then it increases until the x value 2, bracket because it's a solid dot, and then a union to glue together with, starting at 5 with a bracket, because that solid dot exists, up to 7 with a bracket because that solid dot exists. Got the increasing. Now we're looking for decreasing. So I see that it decreases from here to here. I see that it decreases from here to here. I see that it decreases from here to here. Write those intervals in terms of the x values, and since they're all solid dots, we will include them with brackets. That is from -10 up to -8, bracket, union, -2 up to 0, bracket, union, 2, we are going to use a bracket because of the solid dot, up to 5, close the bracket. So those are the intervals on which we're decreasing. Then we want to look for any flat spots, but notice that there really are no flat spots, and therefore this is constant nowhere. We want to ask, is there an absolute maximum? That is, does there exist a largest value for the entire function? And notice that that's it right there, that 210. So our absolute maximum is the value 10, but it occurs at the x value 2. And so the maximum, the absolute max is 10, and it does specifically occur at x equals 2. Does this thing have an absolute minimum? The answer is yes. Notice that I have a smallest value here at -8, -4. So that is, our absolute minimum is the value -4, but it occurs specifically at the x value -8. Do be careful about those questions. Now we want to talk about relative maxes and relative mins. Now, if we're looking for relative maxes or relative mins, it matters that we can find what's called an open interval. And so an open interval is really this idea that if you can place your hands around a piece of the function, is there a smallest or largest value between your hands, then it exists as a maximum or a minimum. So, for the record, endpoints cannot be relative maximums or minimums. And the reason is that there does not exist a way for you to put your hands on a graph to the left of this value -10. You can put it here, but you can't put it over here. So there does not exist an open interval such that that point there is the largest value on an open interval. But you can put your hands around this piece here and notice that that is a minimum. You can do the same thing here. You can put your hands around this piece and notice that this is a maximum. Hands here and notice that this is a minimum. Hands here and notice that that's a maximum. Hands here, that's a minimum. So if you can put your hands on the graph, still touching the graph, and show that there's a largest or a smallest value, then that's the relative extrema, or more specifically relative maxes and relative mins. And so the relative maxes can be listed as the y values, where they occur at their specific x values, or sometimes you may need to enter them as ordered pairs. So just be aware that there is a variety of ways that you may have to enter this. Be careful about the question. And so I'm going to put that these relative minimums and maximums occur at specific values. And so the relative maxes will occur at -2, 6, and also at 2, 10. And remember that if anybody asks you what that relative max is, the answer is the y values, so 6 and 10, but they occur at the x values -2 and 2. Then for the relative minimum, where do they occur? The relative minimums occur at all the troughs. So those are going to be the ordered pairs -8, -4, 0, 0, and 5, 0. Then once again, if someone asks you what are the relative minima, they are -4, 0, and 0. But if they ask you where they occur at x equal -8, 0, and 5.